All right, welcome. Um, I will continue where I left off. And last thing we did was getting things to build, because it turns out that I needed a type, an integer type that is not a standard type, an LLVM type that was like 24 bits or something like that. So I had to introduce this ABI type. And right now I don't know if like this is sufficient or if I need something else. I have most of the code that I need for x64. I haven't implemented all the code paths yet, so I will basically continue refactoring this code until it looks a bit better. And here I already started by putting this like in the struct with attributes, because I'm thinking maybe there will be more things that are more like attributes. So we'll see. Yeah, and I will just make sure that it compiles first. I love having things that compile. I don't like doing things in like big chunks, because then you don't really know if where you messed up or if something broke or something. I know now I have a lot of tests, but they will not work right now because the function compilation is so different. So before I go into that and do all those fixes, I need to make this work. And we have, just to repeat, like what I couldn't say. I mean, I said I think in the beginning of the last Twitch, but I managed to put some music on. I didn't know Twitch picked it up, and so it erased the beginning of that whole Twitch stream. So there are a few places when you want to do the create an ABI, a C ABI or any ABI to implement that. There are different places where you need to do stuff. So you have first, when you make a call, I mean the ABI is about how you make a call in a language. So when you create a function signature, so that's like the first place, because maybe you don't want to pass in the struct as a struct, you might want to pass it in as some variant of some flattened, maybe the struct might contain like a 2 ints, then you might have the function actually taking 2 ints rather than a struct. So that's in the type, the function type itself. And then we have, when you do make the call, then you must take the parameters that you think you have sort of from the code, and then mold it into whatever the actual function, actually what sort of arguments it actually takes. So in the case you have the struct and you want to split it into 2 ints. So you do that when you do the call. You basically take the struct, split it into 2 ints, and it's like do the call with the ints. And then you have the second thing is that when you get the result right from that call, that result might be or something whatever. So it's actually returning the struct or whatever. So that's not at the call side, but then inside when you do the create the function itself using LLVM, first you want to mark up the arguments, some of the arguments. Maybe this something is like a struct return value, then you mark it up with sret. So because it's the pointer to the return value, so we mark it as sret. And maybe something else is by val, so you have to mark it by val. So there are attributes to put on this. We already made the function type, but you have to annotate the parameters on the function itself. And then in addition to that, you also have when when the function thinks that it's going to get a struct, for example, like the struct. But it's getting 2 ints, so you have to like create a struct and then put those ints into that struct and then like hand it over to the rest of the function. So you have like and then you have like given a return value, and the return value might not be what you think is the return value. Maybe you have a struct, so you instead of returning the struct, you actually copy it to the pointer you get for the struct. So the return value, passing the return value and taking the return value and using it, and like both sides of the parameters, both sides of the return value, and then the function prototype, and then the annotations on the function arguments. So that are like 6 places, right? 6 places where you have to use these ABI arg info in different ways, and so that's after you already figured out what the ABI is supposed to be. So that's why the code looks like this. So here we look at the function type, and the first part here is like, okay, it's a return value, and I have a bunch of to-dos here, as you see, and then we have each parameter, and then we have a few to-dos there, and then we have the same at the call expression and function when you generate the function. But I haven't figured out if all these are necessary, all these types are necessary, if I can change them. So for everything I implement, I'll also do some research. So the question is what we're going to do next. So we have this direct pair. Now the thing is, like, the first question I ask myself, because it's a return value here, is this actually used for a return value? So it's a direct pair, it's only generated here. I'm using find usages, that's my go-to. So I have, it's only generated once here when I want a get argument pair return, and then I look at, oh, it's a, here we have it. So we get this argument pair return, and we do it by forming a first class struct aggregate with the high and low part. So we actually do that. I thought these were supposed to be handled by doing by not putting those in the struct. So that's interesting. And maybe I should postpone that, but that at least seems to indicate that some of my code is wrong. I need to mark that quickly before I forget about this. So we have the direct pair, and now it's thinking like, okay, we have a direct pair, maybe we should do that as a direct pair that is a pair. But like lately I've been thinking that maybe that they intended it to be a struct, and it looks like that is the way it's supposed to be. Hang on, here I grab this pair, and then so let's see here. So I'm just going to, this is when you emit the parameter. So in this case, because this one this is something I didn't implement yet. So okay, so we get something from the parameter. Okay, look here, I am taking 2 parameters, and I assume that I want to take those 2 parameters separately, but that might not be true. And the only way to know whether this is true or not is to look at I guess, LVM, or try to provoke this into happening in Godbolt and see what it actually creates. So I have to figure out how I create a direct pair. I get a pair. I guess the return values are usually simpler to figure out because there are fewer cases. So I have, I guess, 2 pieces in my struct, and 2 of them are they are like 16 bits. So I'm going to try to recreate that in Godbolt. So I'm actually going to do something on the side here and see what happens. So I am returning I'm just going to make an extern, no, I have to make a function. So it's going to return something. Now, unfortunately, you can see what I'm doing right now. Just gonna look at Twitch and see if you have any questions. Like, let me know if you have any problems hearing me, or if, like, anything you want me to explain anything. All right, let's see what I got from this one. So that one just gave me an I64. That was too little. So let's see here. Now I actually get a I64. So, and if I take another one, let's see that I'm just going to make sure that this is, yeah, okay. So the thing is, if I have a struct which is 2 elements that are 64 ints, then I should be creating a struct for that. So in this case, like this blue here, this is a bad thing, a bad example. I'm just going to take this blue fun get something x, and it's going to return a blue, and this looks a bit different from C. Okay, now I'm going to run this, and I'm going to, okay, yeah. This is bad. I mean, this is the most, the strongest case for removing funk is that I do this wrong every time. All right, so we have something, and I think it's going to be sort of wrong, but I don't know. Guess something is going to give you, yeah, so it's an I64, that makes sense. So now I'm going to do like this. So now it's going to hit a to do, I think. Right, yeah. So here's hitting a to do. And the reason here is I'm actually doing this the wrong way. So if it's a direct, hang on, it's like a direct pair, all right? In this case, what we want to do with the function is that, let's see, okay, so the function declaration, if the return value is this, then we're not going to do anything if it's, sorry, this is for the attributes. So, okay, so the return value is elsewhere. This is not here, this is the wrong one, so here. So if it's a pair, then we're going to create a pair, so the return type is going to be an LVM type. You're going to take the LVM, create struct something, struct struct type. So, and we're going to have two elements, and now we need a block here. So LVM type ref types, and it's going to be a two element one, and it's going to consist of LVM ABI type of regarg info pair direct pair low type, or the low extent type if it's there. Otherwise it's going to do like this one, low type, and then we're going to have and the second one is going to be a LVM API type regarg info direct pair high type. And those are likely to be the same anyway, but types are two and they are not packed. So this is the return type. That won't break. Okay. So this would fix like one place, and then it's going to be like happen in another place as well. So just anticipating that. Here in the function, we are going to emit the return value. So emit return ABI, and now we want to emit this one, direct pair. So now we have to create this type again. Seems a bit wasteful perhaps. I can store this later on. I'm not doing it right now, but I can do that. So I have the info. Why is it called regarg info? Bad me. Retarg info of something. Regarg. All right. So info, and we have an info, and now we have a problem. So this is the type ref return type, because we have this one. So this is going to query something into something else, but this is not going to be sufficient. Okay, what's this return? Okay, so we have return type use up there. Okay, turn LVM type. Right, but this is not good. I can't queries that value into one of those if the low type is not big enough. And I think there is one case when this happens, so I'm just going to investigate when does that happen. So we have the set here, we get the direct pair, and we get the return, and we do that by taking new plane, right? And that makes sense. So if it's a float, then we're going to extend with a type double, otherwise we're going to extend with a type long. But how does it extend that? So that is interesting. And to find out, I will just try to get this working here. So, okay, I got it. No. It made a small one. Bad. Maybe if I make a char here. So let's see if I can provoke it. Yeah, I got it into. I got the one I wanted. So let's see what LVM does. So it's going to take the. Oh no. Bad. It's going to, because I have some alignment, so it can just put that into the the one it was. So I'm just going to make char something like this. Oh, I get an I40. What the heck? Okay, I guess you have to see this stuff. It's just so sort of surprising when I have struct that looks like this. Hang on, I'll just paste it here. So this is the struct. Okay, in this case, I really would expect this to move into sort of various stuff, but what I get is this. I get an I40. So it's actually returning that. How? I have no idea. But I guess, so that's the way it works for oh, let's see what happens when I do that, by the way. So I have, like I had that char thing. Let's do that. I think I should get the same thing, actually, because I do the similar. Boom, I can't implicitly cast, oh yeah. So I need to cast this as char, then I guess. Ooh, I'm hitting something here. So I direct coerce into right, now I'm hitting some nice stuff here. So I have a direct coerce, and the original type is type struct, right? And the type size of that one, and the coerce thing is, let's see what I got for that. So the coerce is emit value ABI type, the direct coerce type is an ABI type. Let me see here. Direct coerce type is a type bits, and it has 40 bits. So how many bytes does it say it is? This would be interesting to know. I think I can just write something like this. Type size original type. It's 5. Oh, hang on. The LBI size of this one will be in something else, I think. Let me just see how big that one is. So it says this one is 8. Mother. All right, that's pretty interesting. Yeah, I didn't expect the 40-bit int to be that size. So what's the store size then? LVM store size of type. So that's 5. Size, I don't know. I think this is like the ABI size. It is confusing me really. So type alloc size. Yeah, if you want to do an alloc, then obviously that is. I don't know, man. I don't know. That is strange. I'm trying to get some documentation on this one. So it's compute API type. ABI size of a type, definition line, that, so type Alex size. And type Alex size is so it's that's actually the is not the store type. So when I say the ABI type, this is actually the store type I want to compare with, I guess. So let's do this. Maybe it works. Okay, I will get some code from here. So now I get this, right? And let's see if I get something similar. No, yeah, I guess the code is different. So I get something, and then I put something, and then I load. Okay, I'm just going to check the code here and what it does in the end. Okay, so it's going to load, align it by. So it's not going to line this one. I'm not aligning that. Load, which I should be doing. Okay. Let me get back to that one. And that is when I do the return value. So return, maybe it's in function. We were there before. So I think it is in the file with LVM, codegen, and the function, and then we have like the emit a return value, and then we do this one, right? So I think this is the one that I am hitting here. So I do the load query. Something. The last thing is no. Here we do this load. I think the correct thing would be to add a alignment to that one. So I am going to do that. Let's add that. So there's a load here, and what you can do is you take that value. So that's the load, and then we can align that. Set alignment on the load, and the alignment should be like I could actually ask I guess the LVM, but I'm not going to do that. I guess I'm just going to ask for the I guess what is this one? So ABI. So I have ABI type. Type ABI. Now, where is that? I have this LVM ABI size alignment ABI type. I can just use the resulting type here and get the LVM ABI alignment of whatever the queries type is. So the queries type is that. I think this will give me the right alignment, and then we'll return this load. So let's see if that looks fine. No, it's aligned to, oh, that was wrong. Whew. Aligned to 8. Okay, so that alignment looks fine. We have a bunch of loads here. I will later on work on getting the alignment because I misread by like way back, and I read it as like, don't add alignment, we'll do that for you, it's more efficient. But turns out that it's the other way around. So now I'm adding alignment where I can. So here we got the alignment. Okay, so we have the 40. Now we're doing the right thing for the 40 bit thing. And the next thing is to go back to the trying to get the this struct. So I am again trying to get it to make me a struct. So maybe now I have a struct. What does it look like? Is it, I have 1, 2, that's going to be an int line, so that's a long, and then I have two, a char, a short, and char, and the length of that one should be smaller. So let's see here. Struct foo. Let's see how long for this. So it's an int. That should give me an offset. So I think this is the correct one. I will paste it in. So the thing to test is something that looks like this. And let's see if it's the pair. So here we have something Cogen X is breaking. And where is that? So it is. I never like these warnings. I need to check those. But right now we're in the middle of everything. I can't do that. But I like doing pauses over this over and over again. Okay, so we hit it. Yeah, awesome. Let me just verify that by putting a breakpoint here. And woohoo! Okay, good. Now I can, since I have that, I can look at the LVM or the Clang version. So what Clang does is, let's see here, it will allocate when it wants to submit this one. That is, so it's going to allocate, I guess, the. I'm just going to make a simpler example for myself here. So it's going to be like an A, and this is going to do nothing. All right. So what happens now? Struct. Okay. I didn't want that. All right. So it's going to take a struct. The alignment on that one is going to make it how big? Apparently big enough that it's possible to bitcast it. And I guess I'm not getting the pair I wanted. So let me just see here. I was just going to add an assert when I get the low extent thing, right? So because this will not happen in the normal case. No, it's not one. And let's see if I can make it happen. I need a float here, perhaps. What happens if I do that? I still get the pair, but what are the parts in here? This is something to think about. I might do the union, the tagged union. An advantage of doing tagged unions is that you don't need to do this, which you have to do when you have anonymous unions. Sorry about that. So okay, you have direct pair wide. Now look at that. So here I have a low extend type. How come I get this low extend type even though I didn't set it? So the low extend type is this doesn't look. It's a plain one, so it's a U. The low type is a U. What? And the high type is can't read. No, it's just bits. Right. So 64 bits. Okay. But still should, it should have been an error. So I guess I need to look at why. Oh, hang on. Didn't I do that the wrong way? Yeah, I did. So sorry about that. No, I should hit this set. Right. So the low type is okay. I think I'm hitting this. Like where do I hit the high start? Ooh, okay, so the low type, according to this, is plain type, which is a U. This doesn't really make any sense to me. ABI type size is bool. Wow. Okay. Yeah, that will break things. Oh, what? Okay, this is insanely bad. Insanely broken. So, okay. All right, so now I have the low extend. In this case, it's a plain one, and there's a null type. Oh, right. So maybe the low extended. Okay, let me see what happens. So, the high start is now, in this case, 8. So the low extend should be null. Did I just make a... Here we go. So low type is now plain. It's a U64. Let's see why we hit that. We have a high start of 8. Then we shouldn't... Oh, if low extend, then we get this. Otherwise we get null. Yeah, that's better. So now we hit it because we didn't actually need to get that extend. I think this will only happen if the beginning is somehow, not quite filling things out. So okay, I hit something else. So it's trying to classify this, and it's actually low class is an integer. Okay, so that's interesting, but class is the up. Oh, I think I forgot something. Pretty sure that should be a break there. Right? Okay, so it shouldn't be able to get to LVM get type 29, so 299, sorry, 299, which is the generating a type. So here we have a queries type. It is a type of poisoned. This should never compile. Something break, but it didn't show it broke or something. Anyway, we still haven't really gotten the thing I wanted, because we are still not getting this weird cost. Now I might have something. So I don't know if it's too small or not. Let's see here. I just keep on messing with this. Alright, so float, if I put in the float, I'm just going to get something else. Damn it. I keep getting structs. And structs are, I guess, okay, but I don't care, if like the problem is the beginning of my struct, the first part is I just doesn't make much sense to me. That's not I64, and I want to straddle that somehow so that it breaks. And maybe I should pack this, I don't know. I don't know, I'm just trying everything just to to get this sort of the case when I have a value. Damn it! This is so unfair. Okay, I have to look at the code again. So we want to figure out this as well. Of course, I'm just going to see what sort of, in what case does this happen? So in this case we're building that, and what is then the info here? So it's a direct pair. Okay, so when it's a direct pair, it's breaking, but still I want to figure out when I get the oh yeah, so that makes sense because look at this time, it's just unfinished here. So here we need to do a to do, guess, and yes, now it has to do that. So the break was just because I forgot to do the to do there. All right, I am going to look at the case when we have a direct pair again. So when do we get that, and how do I manage to provoke it into it's like, in order to satisfy the ABI, we need to, hang on, I'm just going to look if someone, okay, no one is asking me questions. So, all right, so we have a low size and we have an aligned offset. Is the high start. So we look at the, like where would the, oh, right. So if we have inferred that both are 4-byte types, then the resultant struct type is I32, and we won't have a second element at offset 8. Alright, so in the case this happened, to handle this we have to increase the low parts of the second element will stay at the 8 inf. So we can't increase the size of the second element because it will make a success of the end of the struct. Just make sense to me, but if I can make that happen. So if I have an int A and then a float B, so that would be I64. But maybe I have a short A and the short B, and then we put in a char here, and so C char D. I am really struggling to get to this. It makes little sense to me. Okay, so maybe that's an int. Now it's bigger. Now we want a short. So I mean, it is possible, quite possible, given what I've learned of LVM and so on, that it's actually not possible to get a low type which is 32. We want to have get a turn, and we classify this one, and we have a lower result type and a high type, right? So result type, which is a low one, then must be yeah, I think that's correct actually. So we're getting in here. We find out that okay, it's not a reg call or whatever, and we want to classify this, and then we go and see like, okay, it's an integer. If it's anything, it's going to be an integer. It doesn't matter which one it is. So it's an integer on the return type. Or hang on. So it's a struct. So we're going to try to do that, and we have a union or something. Here we get a member, and we have 2 members, and we have, if it's not aligned, Then we put it in memory. Otherwise, we try to continue classifying these parts, and we have the high class, which is like if we do something. No, this is memory, so this is not happening. And this is memory, that can't happen. So we still have the offset. Now the offset is whatever the offset was, plus something else. And at some point we can actually straddle those. Oh, here it is. But I mean, the offset to actually change anything in the high class, we need to go past the low class. And I can't see that that is happening at any time. Possibly with an array. So I'll try that. So I will put an array in there. So let's say we have a char and we like put a few of those. So we have 4, or we have a char. Like I think I need the something for. So C4. Let's just continue. 5, 6, 7. All right, so sure, and then we have the 8. And we have a C, and then we have another, it's like a D. Now, 8 will put that one in. This will just be returned as 964 every time. I'm trying various various variants of this, but it turns out that whatever I do, I end up with something that LVM doesn't want to lower the way I think it should be lowered, or it might lower it. So it's sort of confusing right now. Maybe I don't know, if I put an alignment or something on attribute. Now I'm like trying to put an attribute on some things here. Line 4. See if it gets some. I'm trying to get some weird alignment to things here. Guess maybe I can get it. Weirdly aligned. So okay. I'm just going to try to get it. I don't know. Really don't know. Because as soon as I get something that can be aligned, I suddenly get a like this size of like the struct will just expand too much. So now that was 6. If I add this and end, so 3. Just desperately trying to align stuff to get some sort of behavior like the one I expect to happen. Somehow I can't get it to happen. I guess short and another short maybe. Still desperately trying to get this error here. So no idea how to do it. Yes, seeing here if I can put it there. 4, 5. No, it is not bloody possible. Question in stream. Okay, right. Do you check for unaligned members for class memory? What do you mean by that? There is a realignment stuff. So because whatever you do is going to have. Let me just show you that. We have the following. Let's see here. Org info. So we have the realignment thing. So it's indirect realigned. So in this case, if something has an alignment that I need to pass, that is different from the ABI alignment, then this will be realigned. But that's not really the question, right? Like, oh, okay, sorry. It's like, yeah, if n is the aligned, this becomes memory, I guess. So that's what happens. Hang on, it's like this is already handled here in the classify somewhere. Here it is. So you got this. It's not aligned, then you get all this stuff. So it moves to memory. But and this is straight off the Clang code. So this is what Clang does. But the thing is, what's confusing me is that apparently in Clang it's possible to get this situation, which is here. So this one, like you have this situation, and I can't get that to happen, because when you actually have that, it will. Oh, hang on, I haven't tested one more thing, so let me just see. I was always using the using normal ints, but I could put in a struct there. So if I have two structs or a union or whatever, so it's an int inside the struct, and then I have another struct, and it's again it's an int. So let's see what's No, that was not possible. Maybe if I have a union, can I provoke it into doing something else? No, that didn't have help. So I don't see how. Let me just show you the code again. Right. So you're actually looking at it, but this would require that the high type is an I32 and the low type would be an I32. And I just can't see that happening. And that's the low extent thing. So maybe it doesn't low extent. Right, so let's drop that for a little while and then we can assume that the high type and the low type are actually correct. In that case, it's actually pretty straightforward. So we have the direct pair, we can take that one. And we are going to, we have the return ABI, it's going to emit this one. We're going to make an alka aligned with, no, emit alka in the context with this return thing, and we're just going to make it aligned the normal way. And then queries. So we have value, we want to return it, but in order to do so, we instead take something and make it into this VM type, and then we bitcast it. Cost as bitcast. So we're going to bitcast this into take the context, and I take the value, which is the pointer, and I want to take bitcast it to the type, and let's see if this one does a get pointer. No, just going to go for that. So oh, I lost my place. Where was I? So all right, so we do the bitcast to the original return type, so whatever that was. And now we can, that means we can do a store, build store. We have you. Right, and then we have the pointer here. So context, sorry. We should probably have an align store thing. So we have the builder, so build store. And then we set the alignment, that one. set the alignment on the store to whatever the ABI alignment is of the return type, right? Because that's what we did the lookup. I guess. So that was wrong. I have this convenience functions. A VM API alignment of that type. Okay, now we have the value, and now we can do a load and put that into the return parameter. Return is going to check that it's just what it's supposed to do. Right, so, oh, how did I lose that location again? Oh, I was doing coding in here. That's bad. Right, so now it's right this. Okay, so now we can emit by doing a load. So we are going to emit load. And again, this is not what we want. Maybe we want to create something nicer. So I don't know. This set alignment is getting a lot of these, you know, these. This is actually like queries, and why don't I do that? So value ref queries. You can call emit queries value to queries, so context of the queries type, which is the return type, and we have the value, which is the return value, and the original value, which is the return type. Okay, so that was a bit simpler. Why didn't I do that to begin with? Because I forgot how it worked. So that looks pretty simple. And then we want to be able to take that as well. So we're going to look for the next use of that. So the corresponding use is after the call, we get this value back, I think. Yeah, so we have the call and we want to convert that. So we now need to figure out what was the actual value here. So this was the value, remember? This was the type and everything. And we create our type again. This might look wasteful, but I don't think it will cost me much. I can later store this one. This is something I was planning to do anyway. So we do a from queries instead. So we're going to change the call. It's going to be that, and we have the return value. So the return value is the call, and then we expect the return type to be that, and we're done. So it looks nice. Function definition not allowed here, and I have done something bad to the code. And now it's spinning. So what happened there? What did I break? Let's check what the commit was. The breaking was in Expr. That looks okay. There is a missing scope here, probably. So okay. Oh wait, no, that looks okay as well. It's okay. And here, that's okay. That's okay. No. What did I do? somewhere here. Oh, of course. Boom, it got upset again. So the return type is a not type. So in here then, the type size, whatever I do, is like, okay, char. The type size is 12 for this one. Does that make sense? It's two chars, and then it's going to be aligned on the next one, and that one's going to line, and then we have this one on the last one. So we have hang on, I don't think this is correct. Types LVM store size of type LVM type original type. Okay, well, let's do it like this. We add a unsigned x equals store size of type LVM type original type. Oh, target retail ID out. So the store size for this one is that. So the queers one is in here, and the top is so the high type is a type plain, and it is a F32. And the low type is a type user. So 12. Apparently this one is LVM store size of queries. What is that? It's 16. Mother. Yeah, damn it. That's correct. Like if you think about it, that is correct. Let's see if I can reproduce that, because if it takes a U64, then suddenly the alignment is 8, right? So what happens if I do this? So it's like I64 in the float, right? So, and it's going to line that by 8, okay? And then it's going to put that into this thing, and this other thing here is going to line that by 4. So consequently, I guess this is going to be different again. So what's the ABI size then? LVM LVM ABI size queries. I want the 16 as well, so nothing matches my yeah, and that makes sense as well. So it's they're not going to match basically. So this assumption is, hang on, there's like one more thing, which is like the store, after the store size is there's like this alloca size, I don't know what's that. So it's like LVM alloca size something, store size, pointer size, size of. You know, what does size of say? So LVM, like what do you say? LVM size of queries. Oh, that's an opaque value. Damn it. So can I get something from that? So I get like the LVM value as to int something, int value ref value get value name get used blah 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 const something, const maybe as a constant. Here's a constant construct const something. There is some, oh, here we have like this one, const int gets next, this one is the one. Edit that one, so I want this thing here. So let's say, see what it says. Now this one is on a return type. So question, when will you commit? Oh, this looks bad. Okay, I'm just going to look at this. I will commit when I know that everything, I am committing small parts, but I'm not pushing this to the repository until I'm, you know, right now it's so horrible in my eyes that I don't want to really, I don't feel this is like suitable for looking at it. I want to confuse basically because some of these are like, oh yes, ideas, and you know, this is a sort of a thinking process for me. Oh, I got this, the original type, the queries one, damn it. Oh no, that was the one. Oh damn it. So I get 0 for that. Okay. I guess I just have to, you know, ignore that and okay, it's not the same type and whatever. Maybe I can just say that, okay, the storage size must be, I don't know, this must be less or equal to that, I guess. And now I reach some unreachable thing. Where did I go? Okay, so probably did the same thing as before. That is, I want to return a value, and I have some info here, which is the direct pair, and I'm doing a break, not a return. Yeah, classic. Okay, it doesn't match. That's good. Because that's something we can work with. So let's see why it didn't work. And by the way, I'm just going to make this direct stuff. I probably have to quit in the middle here. Anyway, we have the return value. We are like having our whatever it is. It's blue, and we just going to query that too. This is not going to work because alignment on this one is different, right? So we want to actually do this differently. When we want to queries, we want to have we want the target to be query, so this won't work. So function, but this is something else, right? Function context. Oh, I'm probably doing something weird here. Oh, struct. This is also why I think stuff didn't struct in context. I think I also need to make a help function for that. So I think that was the name. There it is, 2 places. Struct type, and okay, let's just. We end up doing this a lot, actually. So I think I'm just going to make something LVM cogen type, like LVM type ref in context get to element struct, and then we have like one type. We're just going to take the this, and then we are going to do whatever we were doing here, but in the right way. So we're just going to take a low and a high, and this is super simple. And then we do struct type in context. That means we need a context. And we get it from here. There we go. Okay. And we want to have that in the header file. So I need to order these later on. Struct type to be a bit more consistent, maybe. All right, then we have all these LVM struct type. Let's see how they probably. Damn it. Open and find window. Okay, good. So, right. We have this. So gen context, emit 2 element struct context, comma, this one. It's pretty long. this one. And end. Oh, lovely doing formatting in this small window. Okay, indenting this one is not so. I need to shorten this one. Maybe two struct. Two struct. Two struct. Okay, so I'll be maybe type. Right, and then let's look at the other cases. Here we have one. In context emit two struct. Context. We have the low type. So this is something that's wrong, by the way. Now we have these, our friends from before. It's getting pretty long because of the nesting here. So, and this is also something to look at later on. Here we have some other struct type. Again, it's the pair, I guess. Oh yeah, so it's the same thing as we had before. Maybe I could just copy that from the last one. You know, it's getting somewhat repetitive. This one. And like there's a strong argument for actually storing this by the now. You know, we can store this without actually the return argument info knowing much about it. So it's sort of encapsulated. Okay, so here we have the return arg. So here's arg info. Yeah, lovely and consistent. Something to look at. Okay. Were there any other ones? Here we have one. Again, but this is the complex, so this is nice. There's something new here. So it looks like every time I do this, I am either having an ABI type or a regular type. So there's an argument to actually make that more convenient. And then finally this one, get, oh, that was my helper function. Okay, let's see if I got all of them. I didn't. Not quite. So we have this one, and then we have the end. Okay. Oh, and we're missing the context. And format that a bit. Okay, that actually compiled. So let's see what did it get the wrong thing there. Right. Where are our tests? Here's our test fragments. This is just junk. So we get it. We sort of, okay, let's. Okay, here we have it. So we bit cost below to that. We do a bit cost of this one to that, and then we do a load aligned with 8, which we can't do because actually we load that from this one, which is aligned by 4. So the query's loading thing there is wrong. So we omit this one and we want to do the load, and the load needs to, here we have it. So the load can't be on the coerce thing because what we actually emitted was the other one, which is the temp. So, and the temp had an alignment originally, which is, maybe we can align this one actually. I guess we could align that to the resulting thing, because we want the alignment to be at least, we want it to be like the biggest part of those two. So maybe best alignment is max of LVM ABI alignment of the queries type, and the LVM the alignment of type ABI alignment of the original type. So if we take that one and then we do this alloca meet alloca, and we do that with alignment. So we take we take this type from mem, type, and we do an alignment which is the best alignment that we can have, and we do that, and then we store, and then we take that and make the store you really need a store that is aligned. So now I'm so annoyed at this. So unsigned, void LVM store, and we have value. So what's the order there? So we went to store, we have a context, we have a value, which is the pointer. We have the value, and we have an alignment store aligned. And then we're going to do a build store, taking the pointer, and then we just going to LVM set alignment on the ref and set that to alignment, and then we're done. Okay. Go away. So So instead of this, we're just going to do VM store aligned, and we set the context, and we have the temp, and we have the value, and we have this best alignment. Now it's stored that way. And here we want to set alignment, and again maybe we are just going to build load, like take the load and do this code and have, you know, LVM load aligned. Load aligned, and we have the pointer, and we need to have the type. Like we take the type, and we have the pointer. And then the alignment. It's going to turn a value. So we do the build load thing. So it's the type and the pointer and the name for this. So how often do I actually get something? Okay, so maybe name, and then we set the alignment on this store, and then we return the value. Load, sorry, and we put that one as well. So now we do the bit cost, and then we do LVM load aligned with the context. Have the queries type, the temp value, I would say like the same thing, queries, but now we have the alignment, which is the best alignment, so we can use that one. Sorry, that was the wrong order. So, and then we just return that one, so we can clean it up a bit. So now we should be having, you know, the correct alignment for that one. So let's see here. So it's now we're, yeah, here. So we do the whatever you have. We have a bit cost to that, and now we're going to do. You're going to have the queries temp. The queries temp is where? So the queries temp is this one, and it's going to be the right alignment. I don't know if that's correct. Like, actually I could start with, like, the queries temp here could actually be the like the queries type, right? And then we still store this. We actually do the bit cost first, and put that, take it to a pointer to a of the original type. So right, so we take the bit cost, do the bit cost. So we have the value, right? We are going to create the queries place, and then we do a bit cost on the type. And now we are going to store it as if it was the I think that's correct. No, we just we want load it from there. We will load it. No, we have the temp. We have VM value ref cost, and this is the one we store to, and then we load from the this one. Right, let's see how that looks. I think this maybe feels more correct. So we allocate this one. Now we take the value, whatever that was, like we bitcost that one, do a mem copy, and then we do a load. From that, we get this. So I think that's a better way to query things. Of course, we should always be taking the biggest one. Put that in there, I guess. So there's still some other question or so. Okay, hang on. It's like other window is invisible, by the way. Yeah, unfortunately it just takes so long to switch between them. All right, I guess we're like somewhere. We gotten somewhere now. It's not quite done yet. I need to keep investigating if this squares will happen, and I don't know. I just, in case this, like, I guess the one we want to do it squares differently, right? We want to, what do we want to do when the alignment on one is bigger than the other? I guess this will be okay. All right, and then we have similar things here. So in this case, we actually do it like this one, start with the queries. And we should do this, we should again sort of like try to take the best alignment of the two. And then we should do the store aligned. Like here we should get the best alignment for that one. So instead, like get the best alignment. Then we store aligned with the value with the best alignment possible. And then we do the bit cost to the new type. And we do a load again, and we load it aligned, VM load aligned context. What was that? Load aligned context, original type, temp, max, best alignment, something like that, maybe. Anyway, now it has at least has some alignments. Yeah. Okay. I guess that is it for today. We didn't get very far, unfortunately, but it's getting is pretty late here, and but what we are like to do next is basically doing this for the parameters as well, and that's not very difficult. It's just basically copy paste, but not quite. You have to be a different bit careful. But like I said, it was like in the beginning, there are 6 places where this will happen. So I'll need to fix it for all those places, and we only did, I think, 3. So we need to do the parameters as well. All right, thank you for watching. Goodbye.